Okay, so I am out today. We are going to do some notes on trig identities. This is new. We're going to just take the very simple trig identity and learn how to psi identities with it. Okay, that's our goal for today. And then we'll do some review after we'll do some practice with these trig identities, and then we'll spend the rest of the time reviewing for our upcoming quiz. Okay, so we start with the Pythagorean theorem. A squared plus b squared equals c squared. Right triangle. Now we are very familiar with our unit circle. Let's write the Pythagorean theorem. No, if we have theta and this is y and this is x and this is 1. So what do we have? We have x squared plus y squared equals 1 squared. Now we remember that on our unit circle, every x was a cosine of theta, every y is a sine of theta, right? So let's just, x equals the cosine of theta, y is the sine of theta. That's totally legit. Let's do it. We replace it and we get the cosine squared theta plus the sine squared theta. Okay, we're just substituting, equals 1 squared, which is 1. This is the Pythagorean identity. The cosine squared theta plus the sine squared theta equals 1. You need to memorize that. Do is manipulate it algebraically. Because what we're going to do with this is we're going to make substitutions. If I have the cosine squared plus the sine squared, I can just substitute it for 1. What else could I do? Well, let's sine squared from both sides. We could also get the cosine squared theta equals, subtract sine squared from both sides, 1 minus the sine squared of theta. Well, let's subtract the cosine from both sides. So we would be left with the sine squared theta is equal to, if you subtract the cosine squared from both sides, 1 minus the cosine squared of theta. The next thing I could do is I could multiply this through by -1 all the way through. It would change all the signs. This would become the negative cosine squared of theta. This would become negative. This would look like positive sine squared theta minus 1. I'm going to do the same thing with this one. Every sign changes, and I get negative sine squared theta equals -1, write them in different orders, minus 1. Now this is, I have like all these, I can make substitutions with all of these, and that's what we're going to do today. There's another identity of x is equal to the sine of x over the cosine of x. Okay? So what is also true about this, you see that this only works when you have cosine squared plus sine squared. Cosine theta plus sine theta does not equal 1. Only cosine squared plus sine squared equals 1. But in this, because this is all multiplication and division, this is also true. The tangent squared of x is equal to the sine squared of x over the cosine squared of x. Okay? So with these, we're gonna simplify and verify. Simplifying. Simplifying means rewrite this expression with only one trig function. So we use a set of strategies, kind of catalog them. When I look at this problem, I see two terms. I see cosine in both terms. So I'm going to that's a GCF. I'm going to factor it out. So I have the cosine of x, factor it out, what's left? Sine squared x minus 1. Okay? And then I think to myself, oh, I can make a substitution. Because if I flip my page back over, do I see the sine squared x minus 1? Right there. I can substitute the negative cosine squared of x for that. Let's do it. So now we're going to say that the cosine of x, we're substituting this. Instead of this, we're going to have the negative cosine squared of x. Okay? We made a substitution. Now we're going to simplify. The cosine of x times the negative cosine squared of x will be the negative cosine cubed of x. Now let's just classify what we did. First, we took a GCF. Took GCF. Box it in. That's a strategy. Do you have a GCF? Then we made a substitution. Okay? Substitution. I'm often going to shorthand that from now on, but we can make a substitution. And then we can simplify with algebra. Simplify with algebra. We just multiplied it together. Strategies that we'll be using. Okay, let's do a problem. Well, this doesn't have a GCF. They're totally different variables. I can't factor out one. But I can make a substitution. So I'm going to, instead of sine squared, what can we substitute for sine squared? So we go back over here and we say, oh, sine squared is equal to 1 minus the cosine squared. Let's substitute. All right, so we do that. 3 times 1 minus the cosine squared of x. Okay, I just made the substitution. And I write the rest of the equation. Cosine squared x minus 3. Okay, made the substitution. Now we'll do the math. We're going to do the algebra. 3 minus 3 cosine squared x plus cosine squared x minus 3. We're just doing the math. Now what are we going to do? We have two like terms. We have like terms. Numbers, squared terms. So let's combine like terms. And we get, first of all, positive 3 and negative 3 cancel each other out. So they cancel. We add negative 3 cosine squared x plus positive 1 cosine squared x to give 2 cosine squared x. And now that is much simpler. Okay? So let's again classify our strategies. What did we do? Well, we made a substitution. Okay, so let's shorten that. Substitution. We substituted this. Then what did we do? We combined like terms. This was just algebra. We combined like terms. And that was all we did. Okay? All right, now what? We're going to stop the tape, and you guys are going to do this and this for practice. Okay? All right. So now what we're going to do is we're going to verify to prove that the sides are equal. When you're given a verification problem, they are equal. What you have to do is you have to prove it. Okay? So the way we do that is we simplify one side to equal the other. Okay? Generally, we take the more complicated side and make it equal to the simpler side. And generally, too, we simplify the left to equal the right. Okay? It's not always true, but usually true. Okay. How do we do that? And mainly algebra. When I look at this problem, I see three things multiplied together. Tangent x, this term, and this term. I see that these are two binomials, so my first instinct is FOIL. Let's leave the tangent alone for a minute. Just write tangent of x. And then let's FOIL this. First terms, 1 times 1. And then we have outer, negative sine x. Inner, positive sine x. Now I know those are going to cancel. Okay? So I can write them out. Let's write them out. Okay, I have negative sine x, positive sine x, just foiling, and then last, minus sine squared x equals, and then I'm just going to call this the right-hand side. I'm running out of room, so I'm just going to write right-hand side. I'm not touching it. You never touch the right-hand side. Okay? So what am I going to do next? Well, I look at this, and I think I'm going to combine like terms. Okay? So these positive sine x, negative sine x cancel, and I'm left with the tangent of x times 1 minus the sine squared x equals the right-hand side that I'm not touching. Now, what do I do next? Well, I look at this and I say, ooh, I think I could make a substitution, so I check. 1 minus the sine squared is equal to the cosine squared. I can do that. So let's do it. So now I'm going to have the tangent of x times the cosine squared of x equals the right-hand side that I'm not touching. Okay, I'm still not there. I want to be there. I want to get this to equal this. So what can I do? But I look and I see, ooh, I can make another substitution. So let's substitute for tangent. Tangent is equal to the sine of x over the cosine of x. And let's multiply it to the cosine squared x equals the right-hand side I am not touching. Okay, now I look at this, and ooh, now it's coming into focus. These one cosine will cancel, which will leave me with what I want. Sine x cosine x equals, ooh, let's pull this back down. Sine x cosine x. So I'm left sine x cosine x equals, pull it down now, cosine x. This is called, that's a verification. Okay? So let's do it again. Now this one's going to be over here, going to be more complicated. I can already tell. All right. So I'm looking at this, and I know it's writing is tiny, but what I want to do is I have a fraction here, and I'm adding it to this, which isn't a fraction. So let's make it a fraction first, and then let's get common denominators, okay? Now I know that sine x is my right-hand side, okay, so I'm kind of going to put it off to the side for a minute. It's just the right-hand side. I'm trying to get this to equal that. Okay, so what I'm going to do is I need this to have a common denominator. Well, the only possible denominator is 1 minus the sine x. So what I'm going to do is I'm going to multiply both the numerator and the denominator by 1 minus the sine of x over 1 minus, okay? So this is what I will get. I will get the cosine squared x over 1 minus of x minus 1 minus the sine of x over 1 minus the sine of x equals the right-hand side, which is sine of x. Okay. This gets hard to see because you're not used to thinking about variables as functions. But what we have here is a simple fraction. And when we add fractions, we keep the denominator, 1 minus the sine of x. And we combine the numerator, okay? Now, this is going to be this minus this whole thing. So don't forget, when you're subtracting, you have to distribute that negative 1. So numerator, as I combine it, becomes the cosine squared x minus 1, and then distribute, plus the sine of x. Okay, let's extend that a little bit. I'm combining my, it's just like if I had 1/4 minus 6/4 negative 5/4. Okay, all right, this equals the right-hand side. All right, now what do I do? It looks complicated. Think. I want to simplify this to the sine of x. So when I look at this, I think now that I've rewritten it, I kind of see this is something I could make a substitution for. Let's check it out. Cos minus 1 is equal to the negative sine squared of x. So let's substitute. Okay, so what I'm going to do is I'm going to have, instead of this, the negative sine squared of x plus the sine of x over 1 minus the sine. This looks like, what am I doing? Our right-hand side, but there we go. There we go. Okay. Now what we see is we just have two terms added together. And what I'm going to do is I'm going to factor out a GCF. This is just sine squared plus, this is like negative x squared plus x. Let's factor out an x. So I'm going to take out a sine x, okay? In fact, yeah, I'm just going to take out a positive sine x. So sine x, and what's left? Well, there'll be one sine x left here, negative sine of x, and sine x divided by sine x is 1, okay? Over, now I have 1 minus the sine of x, 1 minus the sine of x. Okay, now look at these two very closely, equals the right-hand side. Look at these two. If I just switch order of these, let's just switch that order. Different order. It's really 1 minus the sine of x, isn't it? And if I have 1 minus the sine of x in the numerator, multiplied to the sine of x, 1 minus the sine of x in the denominator, I can cancel out that whole thing. And what I'm left with is sine of x equals, what was that right-hand side? Sine of x. And that's verified. Okay? All right. I'd like you to try both of these problems in the denominator, and then the teacher, once you've given it a try, the teacher will answer for you. So make sure you don't touch the right-hand side, and you must use plenty of room. If you need a bigger piece of paper, get one, because you don't want to go back and say, did I make a mistake somewhere? You know, was it algebra? Compare it to somebody else's answer. Before I go, let's do a thing. Let's list and qualify what strategies we used. okay, in purple boxes. So I look at this and let's write that as a strategy. Box it in. Foiling. What did I hear? I substitute. See that strategy? I substituted. I substituted again. So I substituted once, twice, 3 times. Okay? And the other thing I did was just simplify with algebra. Simplify with algebra. I could always do algebraic simplification. Now looking at the other side, what did I do? Well, I got a common denominator. Get common denominator. That is a big strategy. So box that in as one of your strategies. Get a common denominator. That's what I did here. I saw it was 2 fractions and I got one. And then what I did is once I added fractions, so fractions is one of your strategies. It's just math. That's a strategy. I added her, and then I looked for something I could substitute. And I did that, substituted, okay? And I took a GCF. That was another strategy, that GCF strategy again. I took out the sign of x, I simplified with algebra, okay? So those are your strategies that we're going to be using. Go ahead and give those a try.